Hello everyone. I'm Dr. We are presenting an explainable deep learning ensemble model for improved credit default prediction. I'm Sinja Karen with Kakawa Dennis. So, and in this content we are covering this introduction, related work, problem statement, research questions and objectives, research contributions, methodology and system architecture, dataset description, experimental results and conclusions, then limitations and future work references, final and acknowledgements. So we have some terms here before we go any further. Credit default, that's the inability of a client to pay a debt. And the deep neural networks, those are complex deep learning models that imitate the human brain. Then explainable artificial intelligence, those are tools to explain the decision that is made by the model. Then you have smart to make the combination of a sampling and undersampling that is basically used for data balance. Ensemble learning, this is the technique of combining multiple models for better predictions. It's actually what you are using. So we present an approach for credit default prediction by leveraging several ensemble deep neural network models. We examine various artificial intelligence techniques to help us interpret predictions made by the model. So this paper, we actually reviewed some papers. We reviewed some paper which was all about the long short-term memory and gated recurrent unit as base learners in stacking ensemble framework using multiple layer perception. Then we also reviewed another paper, which is an explanatory result showed by the hybrid LSTM and GRU model, how they outperform both individual LSTM and GRU models for credit score. We actually reviewed another paper, a hybrid algorithm that combines heterogeneous ensembles and tabnet. A deep learning algorithm specialized in tabular data. In this case, it was proposed to address limitations in improving prediction accuracy using single algorithms. So we have the problem statements. Yeah, our problem statement, we are trying to improve the model performance by avoiding the bias predictions. So in this, we must address the data imbalance problem. Then again, another problem statement is to achieve improved predictive performance, enhance stability and robustness. In this, we must find optimal combination of individual models to improve overall predictive performance. Yeah. And again, our problem statement was to comprehend and trust the result of the output created by the deep learning models. So in this, we must understand how the models arrive at particular predictions in order to gain trust from those models. So our research questions and objectives, we based on these questions. How does the performance of a deep learning ensemble model for credit default prediction compare to individual models work? Then what combination of deep learning ensemble model yield the best performance? Then how do different types of data attributes such as education, those demographics or account balance contribute to predictive power of the deep learning models? So, and these are our objectives. We are with our objectives to handle data imbalance in our data set, to implement and compare performance of several ensemble deep learning models, and implement those XAI techniques basically for understanding and interpreting the predictions. So our research contribution, we actually address the class imbalance problem using the smart to make, as I told you. We implemented stacking ensemble models that combined several deep learning neural models. So like ANN or artificial neural network, then the recurrent neural network RN, then LSTM, long short-term memory, then and GRU, gated recurrent unit with logical regulation as a meta learner. We used Sharply and Lime basically for interpreting and the decision that some of our models made. Those are the XI techniques we implemented. So our methodology, we actually acquired the data set from ECI, then we trained these models. Then after training them, remember we want to combine the performance of the models, or we want to assemble them. So we had to assemble them, and with the meta learner, then we reach the final prediction. So we have our data set. Our data set, like I told you, it is a data set that originated from the study conducted in Taiwan, 2005. It's a UCI repository. It's on UCI machine repository. It actually has very many instances, 30,000, and each shows the individual instance or individual client. We have 23 features associated with each client, as shown here. For example, age, sex, ability of the default, such things. So we did some explorated data analysis, whereby we considered we tried to gain insight of how our data is balanced. We actually found there was a great imbalance in our data set, with the default 22% and 78%, the non-default being much higher, which was not quite good. Then we also visualize the distribution of categorical variables, how they were distributed, like sex and marriage and the rest. We also have a correlation matrix, basically to show how different features relate in our data set. And actually, we gain lots of insights with this. We had to see how specific features relate. So after applying smooth to make, we realized our data was balancing. We were able to attain a 50-50% balance, of target distribution after balancing our data set, which is so good. And let me allow my colleague to take on.
So these were tricks. Then we also got the sharp plot, as you can see. For low values of experiments for August and of September contribute more to the model being default, non-default, being default. And you can see here feature importance, payment status of September, and we can also see here in our line plot features like for this instance, the person was more of a defaulter, since the non-default is 0.1, which means defaulting has a higher percentage because of the education level being. Next slide.
Yeah.
So this is our similar features. As you can see, these are the most important features payment for this specific individual. The rate of them defaulting was 80%. The percentage of non-defaulting was 80%, and marriage and sex were one of the features that contributed to them being non-defaulters. Next. Similarly, also got the sharp plot and the model. The GRU model. Next slide. LSTM, and these were the results for the deep learning. These were the results for the deep learning model. Next slide. We also did tests, and we did feature importance, lime, sharp, and confusion matrix for all these ensemble models. Discovered that ANN ASTM model performed the best. ANN model. Next slide.
Okay. Comparing the performance of the ensemble learning models, in conclusion, XAI techniques actually enhance the interpretability of the models. Then comparing or assembling the models also gives the best result. Then the combination of ANN and LSTM model performed the best, as Michael already said. So our future work actually may involve integrating data sources and dealing with large data set to optimize computational efficiency and exploring different ensemble techniques. For example, boosting or bugging methods to further improve the performance and robustness of our model. So these are the references. We actually visited this. Limitations and recommendations. So our limitations, we actually realized were limited by data availability and quality, since we didn't have any control over that data. So that might also have limited us. Then even the data set had some inconsistencies. Yeah, we faced some inconsistencies within our data. Computational resources, these models require ensemble models require high computational resource requirements for training and deploying deep learning, deploying them. So some of the recommendations include we exploring techniques for data augmentations to make more efficient use of data, then optimizing model architectures, training algorithms, and hyperparameter tuning to reduce computational arguments. So we actually acknowledge Mr. Dr. Garwango Marvin for tirelessly providing us with insightful guidance and mentorship throughout this whole project. And Dr. David Jingo has been overseeing how we are progressing. Basic and UCI machine repository for availing us with a free data set, and our University Makerere providing us access to resources and facilities. Yeah, that's all we have. for today.